the LRI program approaches the second half of its timing. We are almost like 20 years now on the road, I would say. The first decade essentially focused on questions around endocrine disruption. And the impact of this research essentially boiled down to a number of methodologies that was brought at the OECD. And beyond that, it developed the expertise within the LRI network to answer a number of questions that we get regularly from our regulators, consultations and other surveys, where the industry has to voice the argument that it has developed over the years. If I look now at the second decade, the LRI program has focused on developing, I would say, methods that are predictive for the risk assessment in general. On the environmental side, we've done a lot of work on the PBTs, the persistent and biocumulative questions. And on the human health side, then I think the focus has been mostly on predictive toxicology from the read across. And there we have a hit with our AMBIT methodology and tool to address this.
Chemicals will dissipate when they get introduced into the environment. There's a lot of ways that chemicals can degrade, either through biodegradation from microorganisms or in other ways. And there are regulatory tests that are available to help us make estimates of how quickly chemicals will dissipate in the environment. But actually, when things happen in the environment, it's much more complicated than it is in a controlled test. And so we observe a lot of variability in the way chemicals degrade in the environment, and we don't have a good way of estimating that variability with these tests. So my project was really all about bringing together lots of data that's been collected over many years from many people all around the world, and building a statistical framework to help us understand that data in its totality, to better understand the factors that influence the variability of these rates. Perhaps with this type of information, we can design better regulatory tests or regulatory tests that are more intelligent, that allow us to make estimates of the actual variability that we would see in the actual environment.
The project is around the use of the ecosystem services concept in applying to chemical risk assessment. So we know that we gain a lot of benefits as humans from the environment, from natural capital. And we can describe these benefits as ecosystem services. So one of the ideas is to think about how risk assessment of chemicals is done in relation to the current approach, and how it might be improved if we made it more relevant to these ecosystem services. So one of the key benefits of having a more spatially explicit approach to risk assessment is a move away from having to protect all species everywhere all of the time. So it's just kind of a fairly conservative but protective approach, which is fine. But it probably means that we would decide to not use some chemicals in some areas in the environment where, in fact, depending on the ecosystem services we want to gain from that environment, we could actually use those chemicals. So in other words, it gives us the option to determine what trade-offs we can have between the benefits we get from the use of chemicals and the benefits we get from natural capital in ecosystem services. So this enables us to move towards a more environmentally realistic approach to chemical risk assessment.
The interpretation of the new methodologies for tox testing is an area of focus where there is a direct benefit for the industry and indirect for the society.